everyone, welcome back to another video of mine where today we're going to be solving Leetcode problem 241 titled Different Ways to Add Parentheses. So before we actually dive into the problem statement, it's just a quick note. This actually is the daily Leetcode highlighted problem, or the challenge problem on Leetcode, and so I thought it would be a great video, or a great problem rather, to go over on this channel. And it actually is a pretty hard problem, and there are definitely arguments to be made that for this to be classified as a hard problem, as its solution isn't very intuitive. But with that out of the way, let's just go ahead and dive into the problem statement. So we're given a string expression of numbers and operators, and we simply have to return all the possible results from computing all the different possible ways to group numbers and operators. And we can return this answer in any order, and note that we actually have to return these different values that we can possibly form in an array, as noted by example 1. So the test cases are generated such that the output values do actually fit in a 32-bit integer, and the number of different results does not exceed 10 to the power of 4 or 10,000, indicating that we can actually have a big O of n squared, or big O of 2 to the power of n, or 3 to the power of n number of operations, as we don't actually have a high value of digits, or basically a large test case. So in example 1, we have an input string expression of 2 minus 1 minus 1, and so we'd output a list or an array of the values 0 and 2, because those are the different unique values that we can actually form with different rearrangements of parentheses within our operations and our elements in our input string expression. Right, we can either have the full parentheses of 2 minus 1 minus 1, so 1 minus 1, which is equal to 0 ultimately, or we can have 2 minus 1 minus 1, which is 2 minus 0, which will output to 2. And so those are the two unique values or distinct elements that we can actually have an output with these two rearrangements of our expressions and operators. So using that same logic in examples 2, we'd output a larger pool of numbers because we have a lot more operations, a lot more digits. We'd output negative 34, negative 14, negative 10, negative 10, and 10. And note that we can actually have duplicate values in our output list if we actually can run into them more than once with a different rearrangement of operations and digits. So we can actually rearrange the parentheses in two different ways and still get the value negative 10 both times, and so we'd still output negative 10 twice rather than just once. So before we actually start going into this code and actually telling you how I would optimally solve this problem, I will give you guys a few seconds to think of a solution in your head. And if you guys can't think of one, that's completely fine. I will tell you guys how I would optimally solve this problem in a few seconds. Okay, so this problem is actually a very classic divide and conquer problem. So basically for each operator in our expression, we'll split it into two parts, the left part and the right side of the operator. Then we actually have to recursively compute all the different possible values for the left and right side after iterating through them, and combine them using that operator for the different values, and simply return all those possible results and store them in a result array, which will ultimately output once we actually store all those different possible elements. So before I actually do that, let's just have a quick base case, right? And our base case is as such. If the expression, and the way we do this in Python is, if the expression dot is digit, if it actually is just a digit, what we're going to do is, we're simply going to return a list of the integer value of expression. And basically what this is doing is, it basically checks if the expression is just a number, for example, the string of just 5 or the string of just 2. If it's just a singular digit, we can simply return it as a single element in a list, or basically a single integer, as denoted by this int keyword in Python. And we'll basically just return that single value as an integer within a list that we ultimately return after we check for this base case. And if we don't check for that, if we don't actually have that base case, then we'll actually initialize our result variable. So we'll say result is going to be equal to an empty list, right? And what this basically does is, it's going to eventually store all the different values that we essentially output once we actually scan through the different partitions in our array for each operator, which is ultimately what we're going to return once we're done with our main chunk of code. So we can basically just have return results at the end of this code. Right. So after this, let's actually do our main coding. So to actually recursively call and do the recursive division part of this, what I'm going to do is I'm going to say for I, and then character in the enumerating, or basically just enumerating through the expression input string, I'm going to check something. I'm going to check if the character that I'm looking at, if it actually is an operator. So basically if it's in the string that we can just define as a plus sign, a minus sign, or a multiplication sign, if it's one of these valid operators, then great, the current character that we're currently enumerating through our expression input is actually an operator. And so what we're going to do is then we're going to actually recursively call and initialize our two pointers from the left and right side of that specific operator of that specific index at index basically I, as noted by this operating function. So if that's actually the case, what we want to do is we want to set left to basically be the self keyword for object-oriented programming in Python, self, and then we'll actually get this function name. Just copy that and paste it right here. And for our parameter, it's basically going to be expression with the list slicing, basically up until that ith index. And we'll get the right variable to be, again, basically the same thing, self.diffways to compute, with the expression, rather than being list slicing of the beginning of the index, or beginning of the first index, or the 0th index of that expression input string, till the ith index to be the ith, from the ith plus 1 index till the end of the array. Right, and that's just basically how list slicing works. For example, if I were to have an array of, let's just say, 1, 2, 3, 4, 5, basically if I want to print out array, let's just say at list slicing 2 to 4, is going to be from the index 2 till index 4 exclusive, so basically indexes 2 and 3, which is going to be 0, 1, 2, and 3, and 4. Basically, all the indices in my array that are basically within the indice range of 2 and 4, which are basically 2 and 4 exclusive, or basically 2 and 3, and so that would be values 3 and 4. That's basically how list slicing works in Python. So once we've actually initialized these two left and right pointers, after we recursively calculate all the possible results for the left and right parts from our operator that we're currently looking at, which is noted by this character in this enumeration, now we'll actually combine those results and loop through the left and right areas of our partitioned operator. And so what I'm going to say is I'm going to say for L in the left part of my operation, and then for R in my right part of the operation, I'm going to actually look if the character that I'm currently looking at in this specific iteration, if it's actually equal to the string of a plus sign, great, we found a plus operator in our input string expression. And so what we want to do is we want to add that value that we can possibly have to our result array. So we'll say result.append L plus R. They're basically the current elements that we're currently looking at, as denoted by these nested for loops in lines 11 and 12. And we'll basically have a series of these conditionals of if and else if statements. So else if the character that we're currently looking at, or basically the operator that we're currently looking at, if that's actually equal to a string of a minus sign, great, we found a minus operator. So we can add to our result, or basically result.append L minus R. And similarly, using that same thought process, we can say elif the character that we're looking at, and basically our operator string in line 8, if that's actually equal to the string, if that's actually equal to the string of a multiplication sign, great, we'll add the result.append keyword of L times R. Perfect, that works completely fine. And basically what this does is for each result in the left and right parts, we combine them using the current operator that we're currently looking at in the char or character variable and store that in the result. And after processing all these operators, we can simply return the list of all the results, which we ultimately have to do after we exit this line of code. We'll simply return the result, which stores all the different possible values that we can actually use from different arrangements of our parentheses. Okay, let's see what I did wrong here. Expression. Let's see. Okay. Okay, it says expression is actually not. Okay. Okay, looks like I just misspelled expression. So let me actually just run this code to check where I actually went wrong. So that's going to be on line, okay, on line 10. Okay, so yeah, so there should be an I here. Sorry about that, guys. I just misspelled this code. And now this should be completely fine, and it should be accepted. And as you can see, it's just about as efficient as you can get. Both runtime complexity-wise and memory complexity-wise, it's actually big O of 3 to the power of n, because we actually have these partitioning of these recursive calls of these left and right variables. And of course, we have this result extra dynamic array that simply stores all the different possible values that we can form from our processing of the input. So basically to kind of just define each line of code and what it's actually doing, first we basically have our base case. So on line 3, the condition if expression.isDigit, it basically checks if the input expression consists of only one digit, if it's a single number, and if it's just a single digit, there's no need to split further or add parentheses, and we can directly return it as a list of one element. On line 4, we convert the number from a string to an integer using the integer of the int or the int keyword in Python of the expression and simply return it inside of a list. And this is done because we want to actually return a list of results in all cases, even if it's actually just one number, right? And then on line 5, we actually initialize an empty list result to store all the different possible computed results from splitting the expression at different operators from the left and right side in our enumerating function. And then on line 6, we start a loop using enumerate, which gives both the index I and the character char of the correct position in our index string. And the purpose of this is basically that the loop will help us identify where the operators, basically the plus, minus, and multiplication sign, are actually located basically at different indices within our expression input string. And once we actually find an operator, we can split the expression into left and right parts. And on line 7, right here, basically this checks whether the current character is an operator. If it actually is, if it's basically in the string of plus, minus, or multiplication, then we actually know that this is a potential place where we can split the expression into two different parts as denoted by our left and right keywords. Then on line 8, when we find an operator, we split the expression into two parts. Expression till the beginning of the index till the ith index gives the part of the expression to the left of the operator. And the expression from the ith plus 1 index till the end of the index, or basically the end of the expression string, gives the part of the expression from the right till the end of your operator. And the recursive call is basically when we recursively call the diff ways to compute the function name on both the left and right parts to compute all the different possible results from each part. The left will contain the list of the possible results from the left part of the array or the string, and the right will contain the list of different possible results from the right part of the string, of our expression string input. Then on lines 9 and 10, we actually loop through the left and right variables. So basically, after the recursive calls, we have two lists of results, left and right, one for the left part and one for the right part. The first for loop iterates through all the values in the left list, while the second for loop iterates through all the different values in the right list. And we'll combine each result from the left part L with each result from the right part R. Then on basically lines 15, based on the operator character that we found earlier, we're basically checking and performing the corresponding arithmetic operations. If the character that we're looking at is an operator plus sign, we basically add L and R and add that to a result variable or array, and we apply that same logic to minus and multiplication signs, and then we'll ultimately return the result once we're actually done storing all of these different values within our result array. So once we've actually looped through all the characters and evaluated all the possible splits and combinations for each operator in our input expression string, we simply return the result list, which contains all the possible outcomes of evaluating the expression with different parenthesizations. And yeah, that's basically how this code works. And for an example walkthrough, if we had an input string of 2 times 3 minus 4 times 5, as denoted by example 2, step 1 is we basically loop through the expression and find the first operator, which in this case is going to be a multiplication sign at index 1, right here, right? And the left part is basically the string of 2, which returns a list of 2, basically because that's the base case. And the right part is basically the string of 3 minus 4 times 5, which we can split further from the minus and multiplication operators. And the left part, in this case, once we actually do that, is going to be the string of 3, which returns a list of 3 as the base case. The right part is going to be the string of 4 times 5, which returns 20 after multiplying it by 4 times 5. And then step 3 is we combine the results of the right part, which is going to be 3 minus 20, which is equal to negative 17. And so the right part turns into negative 17, or basically the list of negative 17. And step 4, we combine the left and right parts for the string of 2 times 3 minus 4 times 5, and that's going to be 2 times negative 17, which is equal to negative 34. And by evaluating all the possible splits for this input string expression, we get the final output list to be negative 34, negative 14, negative 10, negative 10, and 10. So if you guys enjoyed this video and learned something new, please consider liking this content and subscribing to my channel. It really does mean a lot. And without further ado, I'll see you guys in the next video. Bye-bye.